Every launch that touches the heavens begins here.
In a place where the margin for error is zero.
This is the cathedral of creation for the modern space age.
People see the launch, the fire, the speed. They don't see this, the slow, careful dance of titans.
Every single component has to be perfect. Not just strong, but flawless.
You build it piece by piece. Thousands of hours, millions of parts.
And it all has to come together into a single, perfect machine.
The Merlin engine. 9 of them power the first stage. Each one a masterpiece of controlled violence.
You have to balance immense power with incredible precision. Thousands of degrees, thousands of pounds of pressure.
This is the Octaweb. It's where the power of 9 dragons is tamed and focused into a single purpose.
No single person builds a rocket. It takes a symphony of minds, all focused on solving problems that have never been solved before.
Every detail matters, even the final polish. Because out there are no second chances. The build is complete, but the journey is just beginning. Next comes the test of fire.
Thrust nominal. All systems green.
In space, there is no room for error, even the smallest component failure.
Gimbal. This is the gimbal. It's what steers the rocket. 2 actuators per engine, making thousands of micro adjustments.
The forces are immense. Any flaw, any microscopic crack, and the mission is over before it truly begins.
The Merlin engine. It looks complex because it is. It's a controlled explosion, channeled into nearly 200,000 pounds of thrust. This is the heart of the engine, the turbopump. It spins at tens of thousands of RPM.
It's a delicate, violent dance. The wrong mixture, the wrong pressure, even for a millisecond, can destroy the entire engine.
9 engines, 1 structure to hold them all, the Octaweb. Every weld has to be perfect. It bears the full force of launch.
It is a symphony of construction, where human ingenuity guides robotic strength.
The robots get it right 99.9% of the time. Our job is to find that 0.1%.
So even with all this automation, it still comes down to a human check?
Always. See this? It's a void. Less than a millimeter wide. To the eye,
Once every component is verified, the marriage begins. Easy, easy, hold starboard. 2 feet to contact. 1/2 inch to port, steady. And we are seated. Confirm contact.
There is no guesswork. Every connection is measured. Every bolt tightened to the exact Newton meter of force required.
9 hearts, 1 body, a combined thrust of over 1.7 million pounds.
You build it, you test it, you check it 1,000 times. But you never stop thinking about the physics.
Warning, pressure anomaly detected.
hold the test. Abort. Abort now.
When an anomaly occurs, every second counts. The difference between a data point on a screen and a physical problem is isolate the turbopump assembly. I want microscans on the entire LOX feed line, starting from the injector plate.
Copy that. Diagnostics probe is live.
We're looking for a ghost, an imperfection measured in microns that could cause a failure measured in megatons.
The math has to work. Before you can trust the hardware, you have to trust the physics. It's not the inflow velocity.
This is what's at stake. Thousands of components, millions of hours of work, and the dreams of...
Come on, show me something. It's a needle in a haystack made of needles.
Each of these blades spins at over 90,000 RPM, pumping super chilled propellant. It's one of the most highly stressed components in the world. Scanning sector by sector, magnification at 5000x.
Wait, go back. Right there, enhance. My God. There it is. That's our ghost.
In the rotor, the microfracture in the third stage turbine blade. The simulation shows a 97% probability of catastrophic failure.
How many more blades from that batch are already in other engines? How many are on the integration floor? How many are already at the launch site?
The problem was found. Now, the real work begins.
One microscopic crack had grounded the most advanced rocket program on Earth.
At the edge of innovation, the margins for error are zero.
Every test is a conversation with the machine. Sometimes it whispers a warning. That's not sensor noise, that's physical.
In this room, silence is never a good sign.
Abort test, command, bleed pressure to ambient. I want ultrasonic scans on weld seam 7B, now.
To find a microscopic flaw on a monolithic structure requires technology that can see the invisible.
Dr. Thorne, you need to see this.
It's the smallest details that pose the greatest threat. Propagation under load, catastrophic.
The problem was no longer just about one tank. It was about the material itself.
I need a full crystalline structure analysis, priority 1.
Right away, Doctor.
The flaw wasn't in the design. It was in the very atoms of the metal itself. A contaminated batch of alloy.
Platinum. The entire batch from this supplier is suspect. The embrittlement means structural failure under flight loads isn't a possibility, it's a certainty.
The call had to be made. One person's discovery, putting a billion-dollar program on hold.
All teams, stand down from Booster 9 integration. I repeat, all teams, stand down.
The rocket was safe for now. But with the launch window closing, the race against time had just begun.
Warning, anomaly detected. Shut it down. Shut down the test sequence now. Pull up the full telemetry archive for the last 5 test fires. I need vibration data, cross-reference, everything.
Right away, Aris.
In a rocket engine, you're managing controlled explosions. The line between power and catastrophe is measured in microns.
Material stress analysis is coming through now.
There. Right there. It's a microfracture.
At 300 bar of pressure, spinning at nearly 100,000 RPM, a flaw this small doesn't just cause a failure.
Okay, clamp is loose. Ready to extract.
Blade is secured. Moving to install the replacement. This is where the theories and simulations meet reality. The gap between them is where failure lives, and it's our job to close that gap. Test sequence nominal. All systems green.
We got it. It's stable. Success isn't a single moment. It's the culmination of 1,000 tiny battles won.
Good catch, Aris.
Nobody else would have seen that.
Every component, every wire, every weld. It all comes together for this moment.
It's a strange feeling to see something you've poured so much of yourself into begin.
From thousands of hands in a factory in California to its final destination, a launch pad on the coast of Florida.
You spent years of your life focused on a single goal. And then, you have to let it go.
We build them here, on the ground, with our hands. But we build them for up there. It carries all our hopes with it. To the stars.